So let us move on to the next problem. So here you have four equations that is in the term of y equals to c plus 3. This is to find out a solution with a line problem. That is, you have like mx y equals to mx plus 2. So your first column becomes 1, 1, 1, 1, and that is c, and the d vector becomes your t. So here dt, that is when t is equals to minus 2, when t is equals to minus 1, and when t equals to 1 and t equals to 2. And the values of b, that is ax equals to b. Yes, a value, that is 1 is c, 1 is b, and equals to b. These are the b's. b1, b2, b3, and b4. And the question is, you can solve this using a least square method, and you can draw a straight line. This is an approximation straight line, y equals to mx plus 2 with a slope of d. So here you can see the question is, show that the columns are orthogonal. You have to show that the columns are orthogonal, and also find the optimal straight line, draw its graph and write e square, find out the error. And because you don't have a optimal solution, when you don't have optimal solution, you will have an error. So just check that what is the approximation, whether you have an optimal solution or you don't have the trivial solution. So optimal and trivial are same. Interrupt the zero error in terms of the original system. That is when like when x equals to 0, what do you get? That in zero vector, zero error. Sorry, no, interrupt the zero vector, not zero vector, zero error. In terms of original system of four equations. So when error is equals to 0, so if the error is equals to 0, then say what happens to the right hand side is what lies in which state. So we'll see that. So it can be for a column. So let us see. When you see the solution, you can interpret that value. So we have the following. So I told you you can write the a in terms of two values. That is one is the values 1, 1, 1, first column. Second column, these are the values of t, when t equals to minus 2, minus 1, 1, and 2. And these are the values of y, that is equals to b, like ax equals to b we have. So it is in the fashion of ax equals to b. Now check whether the columns are orthogonal or not, was the first question. So to check that, you take a transpose of the first vector and multiply it with the second vector and check what happens. Minus 2 plus 2 minus 1 minus 1 becomes 0 because all these are 1. Just add the second column. So both are orthogonal to each other. So the question is, yes, they are orthogonal. Second is, what was the second question? You have to find the optimal straight line, draw its graph, and write e square. So you have to find out the values of x, and to find that is here it is c and d values. First find out the values of c and d. Just I have written the four equations that we get from the matrix multiplication. C minus first row, you get c minus d equals to 4. Second row, third row, and fourth row, you get this. Simplify them. These are four equations. You can directly simplify using your this one calculator. So I don't have your calculator. I have just calculated the values of c and d. So you get c and d values. That is I call c and d values, and minus what you are getting 1, and my c is minus 2 and d is 1. Right. So you are getting c equals to 1, c equals to minus 2 and d equals to 1. So you have that, just check the exact solution, and just check the error. So error, how do you find out error? From the equation, just you can find out squared error. So squared error is equals to 0. You first check it. So here I will be having how to, you have, that is, here you have what? C minus 2. If you check and substitute the values of c into d, you'll be getting it as minus 4, and which is equal to exactly equal to minus 4. Or you can see minus b, minus 4 minus of this value squared, you'll be getting it as 0. So if you cross verify that, you'll be getting it as the error e square is equals to 0. So when u square is 0 at the point, so we can say we have y equals to minus 2 plus t, because it is just we are substituting the values of c plus dt. So just substitute that. So you have a y equation. So this again represents a straight line. So and you don't have error. So the approximation y and the previous given y all lie on the same line, because the error is 0. So you have the slope is equals to 1. So minus 2 plus 2 mx plus 2. So you have the equation y is equals to minus 2 plus t. Just check that here. Just include minus 2. Okay. So you have got y equals to minus 2 plus t. So same thing when so you have from the matrix A, when t is equals to minus 2, when t is equals to minus 2, y, what will be the value of y? Y will be, that is minus 2 minus 2, it becomes minus 4. You can check the value of b in the given equation. And when t is equals to minus 1, y value becomes minus 3. And when t is equals to 1, the value becomes minus 1 this point. And when t is equals to 2, minus 2 plus 2 becomes 0, right? So you can say minus 2, you are getting it as minus 4, minus 1, minus 3. These are the values of second column and fourth column, that is b column. You can check this here. You can first column of this matrix A, that is t, minus 2 you are getting minus 4, minus 1 we have got minus 3, right? This is the column B, that we have got y equals to 2 minus 2 plus t, right? So this is the line approximation that we can solve using a least, even using least square method also you can solve this. This is least square method itself, but you can solve the solution because you have an optimal solution present here. So the error is 0. That means you have a solution. So you can go for the direct solution also.